Okay, so this is going to be a very quick rundown of my Flagon and Spade prototype project. So this is it. It's a maze in which you're supposed to try and navigate to the ball hidden in the maze as fast as possible. I'm going to do this very quickly because I know the layout. In the top right hand corner you'll notice there is WA, DNS, which are familiar FPS controls, and each of the quadrants of this compass indicate a particular direction that you'll move or pan towards in this case. So this is a game in which you pan with the A and D keys. And so your goal is just to try and navigate to the ball. But you will notice in a second something strange happened. My W key no longer does anything, and I have to press E in order to walk forward. So the conceit of this game is essentially the controls get more and more confusing the longer and longer you play, until eventually you're sort of playing a game of Twister on your keyboard with your hands, just to be able to perform basic meandering, which I thought would be a fun mechanic, but it turns out it's very frustrating and incredibly impossible for dyslexic people to perform. And so, just based on an accessibility issue, I decided not to move forward with this project. But if you don't have dyslexia and you've played this game hundreds and hundreds of times, you're able to navigate to the ball in 85 seconds, which is actually a very reasonable time. I think the fastest we had someone complete the maze in their first attempt was about 200 seconds. So I'll sort of show you how this, how the key switching happens, why the project looks the way it does, and maybe some other things. So the first thing we have to take a look at is that each key has its own input type, and I manually set these up at the start. So A, for instance, is 4, which means left. W will be 1, which is forward. S will be 2, which is backwards, and D, the D key will be 3, which is to the right. So we can know at any point which key does what, and then of course every other key is set to 0. So this is important when we go to actually activate stuff. So I'll show you where the movement is executed first. So we just have an event tick that splits 4 ways, leading into a gate, and these gates exit on movement or panning. So this is forward, backwards, left, and right, or right and left probably, yeah, right and left. And these gates are opened and closed by do forward, do back, no back, etc. And these are just custom events, and these custom events get called in the thing. So the thing is just a macro that I have set up, so I could copy and paste it rapidly. It's not too pretty, but then this is a rapid prototype, so it wasn't meant to be. So whenever you press a key, it enters into this macro, and the macro looks kind of confusing at first, but it's kind of simple. All you have to really look at is these switch on ints. So when you start pressing the key, it switches on this int, and it does do forward, do back, do right, or do left based on the input type. And then when you stop pressing the key, it simply does the no forward, no back, no right, or no left based on the input type again. So it will just toggle open and close on these gates here. So that's how basic movement is done, and it's a fairly convoluted way to do basic movement. But to do movement that switches whenever you press a button a certain amount of times or what have you, this is basically the simplest way you can do it. So the way I decide when a button is being pressed the right amount of time, we have this algorithm here that determines for how long the button should be held before it switches. And after you've executed an action, it starts a timer based on this algorithm here. And the timer is actually linked to this A-drink custom event. I gave up on naming 26 custom events, so you'll have to forgive me for that. But if you're pressing A and the A key suddenly decides it doesn't want to be pressed, this is where it would get called. And we clear the event on release of the key. So if you're holding A and you release it, we don't want the event to be running while you're not holding A, because that wouldn't make any sense. And then when the event does come through, we essentially just call this custom event called drink, amongst other things, which include setting the temp int to whatever value the A key performs. So in this instance, the A key performed the 4 value, which is turn left, so we set temp to 4. we're also going to set the A key to 0, which means the A key won't do anything. And then we get these inputs, which are the what the A key does, and which keys are adjacent to the A key. These inputs are all very important. So you can look down at your keyboard and test me, but Q, S, Z, and A itself are indeed adjacent to the A key in some regard. So the drink key actually gets called here. So we take the adjacencies of the A key, which can be found here in my variables list, and we just do a for each loop with break. So we're just going to check each of these and find the first eligible variable we can. And at one point, I think I had like a scramble or a randomize function, but I wanted to make it slightly more predictable, especially in the earlier levels. And I had this plan of the game having a variety of different movement types, all of which you can enable with you could toggle them on and off. So I'd have scramble the movement type, maybe have it so it's not even adjacent keys, which would be a little bit crazy, but could be fun. So in this instance, we're replacing what the A key does. So the A has been set to 0, and the temp value has been set to 4, remember? And we're just going to go through all of the keys adjacent to A. So it starts with Q, and to save me finding Q on this list, we'll just pretend that this is Q here. First thing it does is check whether or not Q does anything. So pretend this is Q. It would have to check whether or not this value is equal to 0. Because we don't want to overwrite a key that already does something. Because if you overwrite your right and left keys, then suddenly you can't turn, and it turns out it's quite difficult to complete a maze without being able to turn left or right. So we first make sure whether or not the key is occupied, and then if it is occupied, we just return false, which just does the next element in the for each. And this is why we always leave the last element to be the key that you press itself, because this means that if you exhaust all of these elements, you always have one to fall back on. And remember, we set the A value to 0, so it will always return 0 here, and it will always return true. So that's a little bit of edge case prevention there. So if it does so happen that this is 0, that means we're allowed to overwrite it, so we return true on here. And we just set the value to temp value, so temp value is 4, A is 0, so we set A to 4, and then we update the HUD. And that simply appears over here, so we just switch on int, and then we figure out which variable it is. So in this instance, it would be set to A. So we're setting 4 to A, so we come down here, set 4 to A, and then we play a little animation just to sort of visually indicate to the player that the key has changed. And I was planning on adding sort of like a big visual element and some noise and stuff, but this is a rapid prototype, so I didn't get around to doing all of that. And that's essentially the functionality. That's the algorithm, of course, which just takes into account the proportion of time that you're pressing keys, which key you're pressing. So every frame you're moving forward, it's incrementing this pressed forward integer, and every frame you're pressing a button at all or performing any action, you're incrementing the pressed total. Which does, of course, not account for the fact that you can press 2 keys at the same time. Sorry, it does, in fact. Never mind. And essentially what we do is we just divide one by the other and store the calculation in an array. And I think we just call this every couple of seconds, every second. This is just a sort of a proof of concept, getting the dynamic adjustment to work. So it's not 100%, but it was good enough for the prototype. And so once we know the proportion of time you're holding forward, we can just apply this to our algorithm. So we have this variable called difficulty hold, and this is essentially this is a number of seconds. There's a potential number of seconds you can get until the timer activates. So it's set to 20 seconds, but it's multiplied by the proportion of time in which you're holding the key. So if you're holding W, or forward, for instance, 50% of the time, you'll only get 10 of these seconds. If you're holding S, or backwards rather, for probably 1% of the time, you're not going to get very many of these seconds. Which means that, because in some of these tests I was having, the W key, or the forward key, would get changed around a ton, and then the right and left keys would barely get changed around at all. And you can see this in the end screenshot screens. it will show you how many frames you were holding each action for, and you'll see that the forward one is always like 5 times more frequently held than the right or left one. So I wanted it to dynamically adjust based on people's play styles. So this does that, and it's simply, and I think this is quite neat, I just store these in an array based on the index value 1, 2, 3, or 4, so forward, backwards, right and left, and then I can just use this very same integer that I was using for everything else. So I think that's quite neat. And that's sort of virtually everything as to how this works. There's a few other stuff, like I call some animations here, I set the end screen just based on these integers that we've already encountered. I set the end screen timer very sloppily and do some HUD stuff, and that's kind of it. Just in case you wanted to see the HUD. I will release a playable version, probably on Dropbox, so take a look in the description for that if you want to play it. It will be a exe, so it won't be a build, but because Unreal builds are a little bit awkward, you just have to, Unreal EXEs are a little bit awkward. It'll be the first application file in the folder, so you'll probably have to unzip it, and then you just double click on the folder, and then it'll be an application in there, and then you can just double click that, and it'll load you straight up into this screen. There we go. This is the end screen, so it just says, "Wow, you did it! Please send a screenshot of this screen to Max," and so I can collect some of the statistics of how people are playing, and this little stats thing is bound to all of the stats we saw up here. So that's what this is. And then this is the thing itself, which is just a bunch of. This is the this HUD comment text right, left, backwards, and forwards, and then overlaid on this image, which I drew myself. Are you proud of me? So that's essentially how the game works. There's a few funny development stories. Initially I had this on mouse, but it turns out if you have it on mouse, you only need to press one key, and that's W, because in FPS games people strafe with, well, they don't strafe at all unless they're being shot, and this game doesn't have shooting, thankfully. And so I was just holding W, navigating the maze, and then occasionally I'd turn the mouse in order to turn. And there's potentially stuff I could have done with making the mouse more difficult to control, but I think that would have been a little bit too far, perhaps. So I quite like the system because it's a bit more like a twister on the keyboard, which is a bit of fun, where you end up using 2 hands in order to press all of the buttons that you need, although I'm mostly able to perform this with 1 hand so far. And very early on in development, I didn't even have the compass, so I had players trying to complete this while remembering what all the keys were, and I think that was a more engaging way to play, because you had to sort of think about it, and there's a lot more sort of blindly pressing the keys, but I think to some degree that's allowable. And I personally much preferred using that version, because I think it's a little bit more engaging than what I'm doing here, where I'm just looking up which keys to press on occasion. But this is much, much easier to play, and much more accessible, I think. But that's kind of one of the reasons I ended up stopping this project, is because it became something that wasn't necessarily what I wanted to keep working on. Because I had this initial idea, and it just sort of escaped me. But that's what prototypes are for. If I just blindly kept building the project, then that would be equally bad, I think. So I'm glad I noted that it was not going to be as fun as I thought it was going to be, and then cancelled it from that, instead of blindly powering through. And so that's some of the development stories I have from this game. And mostly just people telling me how awful it is to play, including my dyslexic tutor. He said it's actually almost impossible for someone with his type of dyslexia specifically to play this game, because he's just not able to figure out which keys to press in the required amount of time in order to make any meaningful progress into the maze. So that was another reason that I had to cancel this project. But that's Flagon and Spade. I hope you enjoyed listening to how it was built, and I hope you enjoyed playing it through the download link in the description.